Hello everyone. Very good afternoon to one and all. Whether my voice is audible and can you see my presentation? Let me know. Please comment in chat box. Okay, great. Great. Okay. So already we another subject teacher consumed my 20 minutes. So with your permission, I will extend this lecture up to 3:20 p.m. Okay, up to 3:20 p.m. Okay, and the next lecture will be start at 3:30, near about 3:30. So that will be fair enough to cover the some of the topics. If it covers as early, okay, so we'll finish the lecture as early as possible. Okay. So in the last lecture, we have discussed about the heat transfer subject. What is meant by heat transfer? What is meant by heat, and what is meant by transfer, and what is the combination meaning of heat transfer? Okay, and what we are going to cover in this particular subject. So thoroughly we discussed the syllabus, and by taking the simple examples, we try to understand uh, how we are going to learn and what we are going to gain through this particular subject. In the last lecture also we have discussed the prerequisite, that is nothing but what we have learned before learning this particular subject. So that is nothing but basic mechanical engineering we have learned in the first year. Then in the second year we have learned the thermodynamics, applied thermodynamics, and in the third year we are learning now a heat transfer subject. And when you go to the final year, so in final year there will be a refrigeration and air conditioning, that is nothing but rack subject. For that, the prerequisite will be the heat transfer. Okay, so we discuss what is meant by heat transfer. Okay, so transfer of heat from one place to another place due to a temperature gradient, that is nothing but a heat transfer. Okay, and this heat transfer is happening because of the three modes, that three modes are nothing but conduction, convection, and radiation. And for that purpose I have discussed one example also, and I'd like to show that example also once again. Okay, so this is the example we have discussed that. So first man holding one rod, and one end of that particular rod kept in fire, and that particular person is holding, but after some time he feels the heat at another end. Okay, so that is nothing but what the heat is transforming from this region of rod to this region of rod. Okay, from this region of rod to this region of rod. So the heat transfer through a substance which are in physical contact or within a substance, that will be considered as a conduction. Okay, that will be considered as a conduction. Then what is meant by convection? Now one person is holding hand somewhat away from the fire, above the fire. Okay, somewhat away from the fire, above the fire, and that particular person also feeling the heat uh, because of because of molecular transformation of air from this region to this region. Okay, from this region, fire region, to this particular region. Okay, where that particular person hold their hold hands. So the fluid transform the heat from one region to another region. So actually, so fluid transformation or region transformation happen, that is nothing but what the convection heat transfer, the convection heat transfer. Whereas one person is sitting somewhat away from the fire, but then also he feel the heat. Okay, or that particular person feel the heat because of what? So here the phenomenon of a radiation. Here the phenomenon of a radiation. We have also considered the example of a sun and earth. How there is no intermediate medium in between a sun and earth. Then also we receive the heat energy from the sun. So this heat energy transform in the form of electromagnetic waves with the speed of a light. Okay, or we can say that it will travel with the speed of light and with the light waves. Okay, it travel with the light waves with the speed of a light, and when it reaches to earth where it strikes, they bombard their energy to that particular place. Okay, and this transformation of energy without any medium, because of electromagnetic waves, that is nothing but a radiation. That is nothing but a radiation. So briefly I cover this all the three uh, modes of a heat transfer, that is nothing but conduction, convection and radiation. Most important thing to transfer the heat is nothing but a temperature gradient. Okay, so that is nothing but dt divided by dx, or we can say that in a simple language, in an initial stage we required the temperature difference. Okay, we required the temperature difference to transfer the heat. Okay, so always heat is always transferred from high temperature region to a low temperature region. Okay, heat is always transforming from high temperature region to low temperature region. And if you want to transfer the heat from low temperature region to high temperature region, we require some external assistance. That is our second law of thermodynamics. Okay, so here the syllabus of this particular chapter is divided into a three segment. Okay, it is divided into a three segment. So which are that segments? So first of all, we try to understand the basics of heat transfer. Okay, which are the different modes and which are the different laws which govern the heat transfer, which govern the heat transfer. So the law of heat transfer for the conduction will be different. Law of heat transfer for the convection will be different. Law of heat transfer for the radiation will be different. Okay. In that also we try to understand what is meant by thermal conductivity and how it will be vary according to the temperature. Okay, so it will be useful and it will found numerous applications while selecting the material for the particular purpose or for the particular applications. Okay, so modes of heat transfer, basic laws of heat transfer, thermal conductivity and its variation with temperature for various engineering materials. Okay, so there will not be any numerical treatment for this particular modes of heat transfer. Okay, that is 1.1, unit number 1.1. In that, the second segment of this particular syllabus is steady state heat conduction equation. So in this segment, we try to understand the derivations related to the conduction. Okay, derivations related to the conduction for different applications. Okay, so the applications like plain wall, cylinder, sphere, and their composites. Okay, means what? The composite plain wall, composite cylinder, composite sphere, and their derivations. Okay, and there will be a numerical treatment on this particular segment. Okay, there will be a numerical treatment on this particular segment. And the last one is unsteady state heat conduction. Okay, so in that, this is the different phenomena. Steady state means what? There will not be a change with respect to time. Okay, there will not be a change in a property with respect to time. That is nothing but what? Steady state. Whereas unsteady state means what? There is a change with respect to time in properties of substance. That is nothing but what? The unsteady state. And the heat conduction, that will be considered as an unsteady state heat conduction. Now here only one property we are dealing with, that is nothing but a temperature. If the temperature does not vary or it remains constant, then with that will be considered as a steady state heat conduction. And if it changes, then it will be called as an unsteady state heat conduction. Then it will be called as an unsteady state heat conduction. So in that, we try to understand the phenomenon of a negligible internal resistance and the two dimensionless numbers, that is nothing but Biot number and Fourier number, which will be useful to understand the unsteady state heat conduction phenomenon. Okay, then afterward the lumped heat capacity analysis, and this particular segment does not have any numericals. Okay, so numericals for this particular second segment will be there in your final examination. Okay, so first segment is also descriptive and the last segment is also descriptive. Okay, so I would like to recommend these two books, or these books are also recommended by the university. Okay, so first one is Heat and Mass Transfer by R.K. Rajput, and the second one is Heat and Mass Transfer by P.K. Nag. Okay, so best book is, I think, in the initial stage, you try to understand this R.K. Rajput book. Okay, the basics also fantastically covered by R.K. Rajput in this particular book. Okay, P.K. Nag is somewhat difficult to understand. Okay, some of the steps required some knowledge, basic knowledge, but in R.K. Rajput, it is clearly describe all the basic steps also. So, and the numericals are very much easy, and uh, the examiner also prefer this particular book. Okay, R.K. Rajput book. Okay, most of the time, the HT heat transfer numericals are from this R.K. Rajput. So these two books are the basic books, and if you want to refer more books, then I will suggest you Heat Transfer by Sinjal. Okay, so this is the reference book, and you can refer, but the book is so much descriptive, and it will easy to understand. So but you need to study a lot through that particular book. Okay, so Sinjal is one of the book that preferred worldwide to understand the concept of a heat transfer. And in the regional books, we can say that in Maharashtra region or in India, the students prefer most of the time the R.K. Rajput. Okay, R.K. Rajput. You will get the soft copy of this particular book on internet also. If you search Heat and Mass Transfer by R.K. Rajput, you will get the soft copy on internet also. Okay, or else I will share the soft copy with you. Okay, so please note down the names of a book. Okay, so already I have discussed that to understand the heat transfer phenomena, we should have some basic knowledge of a thermodynamics. Okay, we should have some basic knowledge of a thermodynamics. So what is meant by thermodynamics? What we learn in the thermodynamics? So thermodynamics basically, if you check out your thermodynamics syllabus, every time we try to understand the conversion of heat energy to work energy. Okay, okay, or work energy to heat energy. Okay, so most of the examples like that way. Okay, the numericals are also on that basis. So if this much amount of work is done on the system, how much energy will be released? Okay, in that kind of examples. So the thermodynamics, one can say that is the science which deals with the relation amongst the heat and work. Okay, and properties of system which are in equilibrium. Most important wording is nothing but equilibrium. Okay, that will differ the heat transfer and thermodynamics. Okay, what we are doing, we are finding out the properties of a system, we are finding out the conversion or the relation between heat and work at a equilibrium state. At a equilibrium state, that is nothing but what equilibrium is. What, there will not be a further change in the system with respect to time. There will not be any further change in the system with respect to time. That is nothing but a simply equilibrium. Okay, thermodynamic is useful to describe the state of any substance or a matter, and how that particular substance or matter changes its state from one form to another form. Okay, so that is nothing but it describes state and change in state of a physical system. Okay, it will describe state and change in state of a physical system. So to understand all this work, the conversion relationship between heat and work and properties of a system, also the phenomenon of a change of a state, we need to understand the laws. Okay, to understand the relationship, scientists establish some laws. Okay, which are that laws? The first one is the first law of thermodynamics, then second one is the zeroth law of thermodynamics, then third one is the second law of thermodynamics. So these are the basic laws, and that knowledge we require to understand the conversion or relationship between the heat and work and properties of a system which are in equilibrium state. Okay, which are in equilibrium state. So that you have studied in a second year also. Okay, so there are some some terminologies which are used in a thermodynamics to understand the phenomenon. Okay, first one is nothing but a system. What is meant by system? It is one kind of a finite quantity of a matter or prescribed region or a space. Okay, system म्हणजे काय? एक कोणतेही एक region तुम्ही consider करू शकता. Okay, आणि त्याला describe करू शकता, त्याला boundary condition apply करू शकता. So that is nothing but what? The system. Okay, then the boundary. So boundary is one kind of a imaginary or a real line which separate the system and surrounding. Okay, so आपण त्याच्याकडे एखादी लाईन खेचून त्याला बाउंड्री करू शकतो. ओके, किंवा आपण इमॅजिनरी लाईन कन्सिडर करू शकतो इन द सेन्स ऑफ हीट ट्रान्सफर और इन द सेन्स ऑफ मॅटर ट्रान्सफॉर्मेशन. ओके, एका रिजन मधून दुसऱ्या रिजन मध्ये जर हीट ट्रान्सफर होत असेल तर त्या केसमध्ये फर्स्ट रिजनची बाउंड्री काय असेल आणि सेकंड रिजनची बाउंड्री काय असेल. सो दॅट विल बी द इमॅजिनरी पार्ट. ओके, दॅट विल बी द इमॅजिनरी पार्ट. But in case of a matter transformation, we have to consider the boundary in a real case. Okay, in case of a matter transformation, we have to consider the real boundaries of a system. So we can say that boundary is the imaginary or real line which separate the system and surrounding. Then everything outside the system, that will be the surrounding. Okay, everything outside the system, that will be the surrounding. Okay, then next one is open type of a system. What is meant by open type of a system? The system in which matter as well as energy flows inside the system or from the system to the outside surrounding. That will be the open type of a system. So open system is nothing but matter and energy flows into or out of a system. Okay, matter and energy flows into or out of a system. That will be the open type of a system. Then the next type of a system is isolated system. So in which there will not be a scope for energy transformation or a matter transformation from the surrounding to the system or a system to the surrounding. So that will be the isolated system, which exchange neither energy nor matter. Okay, which exchange neither energy nor matter. That will be the isolated system. Then the last one is the closed system, or it will also called as the adiabatic system. So such kind of a system only exchanges heat. Okay, only exchanges heat, not matter. That systems are called as a closed systems. Okay, it is also called as a adiabatic system. It is also called as a adiabatic system. Getting everyone? समजतंय सगळ्यांना? थोडं थोडं लिहित जावा जेणेकरून तुम्हाला समजत जाईल एक एक पॉइंट. Okay, so we'll start with this basics of thermodynamics. Please note down the definition. Now, why I'm taking this? Because when you understood what is meant by thermodynamics, then only we'll come to know what is meant by heat transfer. Okay, so there is a basic difference between thermodynamics and heat transfer that we need to understand in the initial stage only, and then we move ahead for the modes of heat transfer. Okay, so basics of a thermodynamics, you heading as first point. Basics of the thermodynamics. Thermodynamic means what? It can be defined as thermodynamic is the science. Thermodynamic is the science. Thermodynamic is the science. Please note down everyone. Thermodynamics is the science which deals with thermodynamic is the science which deals with the relation which deals with the relation among heat comma work, among heat comma work, and properties of system which are in equilibrium, to stop. Next point, it describe state and It describes state and change in state of physical system. It describes state and change in state of physical system. It describes state and change in state of physical system. Full stop. Next point. To understand, to understand, to understand relation, to understand relation, scientists establish laws. To understand a relation, scientists establish laws. Okay. So basic point. First one, the system finite quantity, finite quantity, finite quantity finite quantity of matter, finite quantity of matter, finite quantity of matter or prescribed a region or prescribed a region or prescribed a region of space, finite quantity of matter or prescribed a region of space, that is nothing but system. Then second, boundary, boundary, the imaginary, the imaginary, the imaginary or a real line, the imaginary or a real line which separate, which separate, which separate system and surrounding, which separate system and surrounding, which separate system and surrounding. Full stop. Then what do you mean by surrounding? Surrounding, surrounding everything, everything outside the system, everything outside the system, everything outside the system is surrounding, everything outside the system is surrounding, everything outside the system is surrounding. Then next, types of a system, types of a system. First one is open system, first one is open system. In that matter and energy, matter and energy flows, matter and energy flows into or out of system, matter and energy flows into or out of system, that is nothing but open system. Matter and energy flows into or out of system. Then next one is isolated system, isolated system, isolated system which exchange, which exchange neither energy, which exchange neither energy nor matter, which exchange neither energy nor matter, that will be the isolated system. Isolated system. Then the next one is closed system. Closed system. Closed system. Closed system. Only exchange heat or only exchange energy nor matter. Only exchange heat or energy nor matter. That will be the closed system. Closed system. Okay. So the next type of a system is homogeneous system. Homogeneous system is what? The particular system consists of single phase matter only or single phase substance only. So that particular system is nothing but a homogeneous system. Okay. So take the example of you can say you consider a jar, and in that particular jar there is only water. Okay. So the water is in only single phase, that is liquid phase. Okay. That particular water jar system will be considered as a homogeneous system. Okay. Now in that particular jar, if you put up some cubes of ice, then that particular system will becomes a heterogeneous system. Okay. So system consists of two or more phases of matter or a substance, then that particular system will be considered as a heterogeneous system. Okay. Homogeneous means what? Only single phase. Okay. Anything, gas, liquid, or solid, any of the three phases, if the substance or the matter phase is a single phase only present in the system, then that particular system will be considered as a homogeneous system. If you consider the heterogeneous system, in that particular system two or more phases of a substance will be present, then that particular system will be considered as a heterogeneous system. Okay, simple one. Then the next one is the thermodynamic equilibrium. Okay, important type of equilibrium. Okay, there are three types of equilibrium: thermodynamic equilibrium, mechanical equilibrium, and chemical equilibrium. So first one is the thermodynamic equilibrium. So thermodynamic equilibrium is what? The temperature of the system does not change with respect to time and has same value at all the points of the system. Okay, what it means? Okay, consider any matter or any substance. Okay, and if you measure the temperature at a particular instant at a particular time period, okay, so it shows that it is 35 degrees Celsius. Okay, and after some time, if you check the temperature of that particular substance, then it is also showing that the 35 degrees Celsius temperature. So that is means what? It is not changing with respect to time. Okay, now if you check the temperature at a different positions of that particular substance, okay, at a different positions of that particular substance, then also we are getting the 35 degrees Celsius temperature only, then we can say that the temperature of a body or that particular substance does not change with respect to time, and it has the same value at all the points of a system. It has the same value uh, at all the points of the system. That will be called as a thermodynamic equilibrium. Then the next type of equilibrium is mechanical equilibrium. Okay, so equilibrium is what? In a mechanical system, if we are there, if you are discuss about the Tom subject, okay, so balancing is one concept in a Tom theory of machine. I think in theory of machine there is a balancing concept. Okay, what we are doing in that, there will not be any unbalanced force remain in the system. That will be assured by balancing. That will be assured by balancing. So mechanical equilibrium is what? There is no unbalanced force within the system or between the system and surrounding. That will be called as a mechanical equilibrium. Okay, that will be called as a mechanical equilibrium. And the chemical equilibrium, so there will not be any chemical reaction within the system, and the composition of that particular system remains constant throughout the system. okay, throughout the system. So if you check the composition at particular position, and if you check the composition of uh, uh, chemical composition of the system at another location, if you get the similar composition and there will not be any time lapse chemical reaction in that particular system, then that particular system will be considered as a chemical equilibrium system. Okay, that system will be considered as a chemical equilibrium system. Once again, thermodynamic equilibrium, it means what? The temperature does not change with respect to time and it is same at all the points. Mechanical equilibrium is what? There will not be any unbalanced force within the system. And chemical equilibrium is what? The composition of the system will remain constant throughout the system, and there will not be a any chemical reaction within the system. Okay, or any time lapsed chemical reaction will not be there in the system. Then that particular system will be called as a chemical equilibrium. Okay, समजते सगळ्यांना? Getting everyone? Please mention in the chat box if you have any doubt, any question. Everyone understand this particular basics? Please mention in the chat box, and please note down homogeneous system, homogeneous system, homogeneous system. System consists of single phase only. 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 Then heterogeneous system, heterogeneous system, heterogeneous system. System consists of two or more phases. System consists of two or more phases. System consists of two or more phases. Then types of equilibrium, types of equilibrium, types of equilibrium. First one is thermodynamic equilibrium. Thermodynamic equilibrium. Thermodynamic equilibrium. The temperature of system, the temperature of system, the temperature of system does not change with time, does not change with time. The temperature of system does not change with time and has same value at all points. The temperature of system does not change with time, does not change with time and has same value at all points of the system, and has same value at all points of the system. That will be thermodynamic equilibrium. Second one, mechanical equilibrium. Mechanical equilibrium. Mechanical equilibrium. There is no unbalanced forces. There is no unbalanced forces. There is no unbalanced forces within the system. There is no unbalanced forces within the system or between system and surrounding, or between system and surrounding. That is nothing but chemical equilibrium, that is nothing but mechanical equilibrium. Then last one, chemical equilibrium. Chemical equilibrium. In that no chemical reaction takes place, no chemical reaction takes place, no chemical reaction takes place in the system, in the system, and and chemical composition and chemical composition and chemical composition which is same throughout the system. Okay. And chemical composition which is same throughout the system, throughout the system, throughout the system. Okay, over. Shall we move ahead to the next point? Is there any question, any doubt? Everything understood? Okay, that is only a revision kind. Okay, so that we'll move ahead with a clear, or we can say crystal clear basic knowledge. Okay. Okay, so just we have discussed that to understand uh, the relation among heat and work, the scientists established some kinds of laws. Okay, the first law of thermodynamics is the basic law to understand the relation of heat and work. Okay, so first law, general statement, we can say that energy neither be created nor be destroyed, and it can change from one form of energy to another. Okay, it can change from one form to another form. Okay, so that is the basic statement of first law of thermodynamics. Okay, so in mathematical knowledge or in the implementation stage, we required some deep knowledge of this particular thermodynamics first law. So it will be mentioned in the second statement that what it suggests, actually what it suggests. When the system undergoes thermodynamic cycle, then the net heat supplied to the surrounding is equal to net work done by the system on the surrounding. Okay. Once again, when the system undergoes thermodynamic cycle, then the net heat supplied to the surrounding is equal to net work done by the system on the surrounding. Okay, net work done by the system on the surrounding. Okay, and mathematically it is represented as cyclic integration of dq is equal to cyclic integration of dw. Okay, so dq is nothing but what? dq is net, or the change in energy, and dw is nothing but what? The change in work done. Okay, dw is nothing but what? The change in work done. Okay, so general statement is energy neither be created nor be destroyed. It can change from one form to another, and to implement this particular first law, we required in-depth statement of a first law, that is nothing but when the system undergoes the thermodynamic cycle, then the net heat supplied to the surrounding is equal to net work done by the system on the surrounding. Okay, and mathematically it is represented as the cyclic integration. Now this is the symbol of a cyclic integration. Integration with a circle is nothing but a cyclic integration. Cyclic integration and integration of dq equal to cyclic integration of dw. Okay, now here what it means, cyclic integration means what? Sum for complete cycle. Okay, whatever the changes happen in the heat, that all the changes accommodated by the cycle. Okay, and what represent cyclic integration of dw? Whatever the changes happen in a work, the summation of all the changes over the cycle that will be integrated over here. That is nothing but cyclic integration of dw, or cyclic integration of change in work done. Okay, change in work done. Okay, please note down first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. Energy neither be created, energy neither be created nor be destroyed, energy neither be created nor be destroyed. It can change, it can change from one form to another. It can change from one form to another. It can change from one form to another. Okay, so that will be the generalized statement of thermodynamics. The next implemented statement will be when the system undergoes, when the system undergoes, when the system undergoes when the system undergoes thermodynamic cycle, thermodynamic cycle, when the system undergoes thermodynamic cycle, then the net heat supplied, then the net heat supplied to the surrounding, to the surrounding, to the surrounding, to the surrounding, to the surrounding is equal to, is equal to, is equal to net work done by the system, net work done by the system, net work done by the system on the surrounding, on the surrounding. Mathematically, mathematically, please note, write down this equation. Mathematically, mathematically, cyclic integration of dq, cyclic integration of dq is equal to, is equal to cyclic integration of dw, is equal to cyclic integration of dw. Okay, over. Okay, now here we have discussed that we need to take the cyclic integration, or we have to sum up the change in energy, and we have to sum up the change in work. Okay, and for that purpose we required the sign convention. Okay, so we have to remember this sign convention while dealing with the first law of thermodynamic and the examples related to that first law. Okay, so and it will be useful for the uh, further laws also. Okay, so first we need to remember sign convention, that is nothing but work done by the system will be considered as a positive. Then second one, work done on the system. Okay, please check out the wording over here. Okay, work done by the system. Okay, कुणावर केली असणार आहे, सिस्टीम न वर्क सराउंडिंग वरती केलं असणार आहे. So that work will be considered as a positive work. Okay, then वर्क डन ऑन द सिस्टीम कोणी केलं असणार आहे, सराउंडिंग न वर्क सिस्टीम वर जर केला असेल तर ते निगेटिव्ह कन्सिडर होणार. ओके, वर्क डन ऑन द सिस्टीम विल बी कन्सिडर्ड ॲज अ निगेटिव्ह वर्क. Then the third, this is about the heat or energy. Then the third point is suggesting that heat received by the system. Okay, heat received by the system. कुणाकडनं हीट रिसिव्ह करणार आहे, दुसऱ्या सिस्टीम कडून किंवा सराउंडिंग कडून. ओके, हीट रिसिव्ड बाय द सिस्टीम विल बी कन्सिडर्ड ॲज अ पॉझिटिव्ह. ओके, पॉझिटिव्ह हीट. अँड वेअर ॲज द हीट रिजेक्टेड बाय द सिस्टीम विल बी कन्सिडर्ड ॲज अ negative heat or negative energy. Okay, so these 4 points we need to remember while dealing with the problems related to first law of thermodynamics. Okay, okay, please note down. We have to remember first one, work done by the system will be equal to positive work, Second one, work done on the system will be equal to negative work, Then heat received by the system that will be positive Q or plus Q, positive energy plus Q. And heat rejected by the system will be equal to negative energy, that is minus Q. Heat rejected by the system will be considered as minus Q. Over. Shall we move ahead to the next point? Now, the second law is zeroth law of thermodynamics. Okay, the law is describe the equilibrium condition. Okay, this zeroth law of thermodynamics describe the equilibrium condition. Okay, so now what is the statement of zeroth law of thermodynamics? Okay, so when body A is thermal equilibrium with body B and body B is thermal equilibrium with body C separately, then body A and C are in thermal equilibrium. Okay, समजा A बॉडीचं टेम्परेचर ओके B बॉडीला समांतर आहे आणि सेपरेट मध्ये B बॉडीचं टेम्परेचर सी बॉडीला समांतर आहे. तर आपण म्हणू शकतो की ए बॉडीचं टेम्परेचर सी बॉडीला समांतर असेल. ओके, सो दॅट इज अबाउट द इक्विलिब्रियम. ओके, when body A is thermal equilibrium with body B and body B thermal equilibrium with body C separately, then we can say that body A and body C are in thermal equilibrium. Okay, so mathematically, if you say, if you want to represent this statement, then we can say that if temperature of body A is equal to the temperature of body B and separately temperature of body B is equal to temperature of body C, then we can say that temperature of body A is equal to temperature of body C. Okay, logical thinking. So please note down zeroth law of thermodynamics. Zeroth law of thermodynamics. Zeroth law of thermodynamics. Zeroth law of thermodynamics. Statement. When body A is thermal equilibrium, when body A is thermal equilibrium, when body A is thermal equilibrium with body B, with body B, with body B, and and body B, body B and body B thermal equilibrium with body C and body B thermal equilibrium with body C separately, thermal equilibrium with body C separately, then body A and C are in thermal equilibrium. Body A and C are in thermal equilibrium. A and C are in thermal equilibrium. Mathematically, if T suffix A, that is temperature of body A, T suffix A is equal to T suffix B, that is temperature of body B. If T suffix A is equal to T suffix B colon T suffix B is equal to T suffix C, T suffix B is equal to T suffix C, T suffix B is equal to T suffix C, then T suffix A is equal to T suffix C, then T suffix A is equal to T suffix C, T suffix A is equal to T suffix C. Any doubt, any question? Getting everyone? Zeroth law of thermodynamics. Okay, the last one is the second law of thermodynamics. Okay, so what it suggests? Okay, so it suggests that the heat is always transformed from high energy level to low energy level, or high temperature region to low temperature region. If you want to transfer the heat from low temperature region to high temperature region, then you have to perform some work, or there should be a work performance agency or some external agency required to perform the work on the system, so that heat will be transferred from low temperature region to high temperature region. Okay, so basically, naturally, the heat is transferred from high region to high temperature region to low temperature region, or you can say that from source to sink. Okay, And if you transfer the heat from sink to source, okay, or from low temperature region to high temperature region, in that case you require some external work agency, or we can say that some external work we need to perform on the system so that the heat will transfer from the sinks to source, from sink to source. Okay, getting everyone? So in a generalized manner, we can say that heat will flow naturally from one reservoir to another at lower temperature. Means what? The another reservoir is placed at a lower temperature, whereas but now not in opposite direction. Naturally opposite होऊ शकत नाहीये ते. Okay, but not in opposite direction without an assistance. Without an assistant. Assistance means what? तुम्हाला external motor लागेल, okay, external pump लागेल, okay, so external compressor लागेल. So that is the requirement to transfer the heat from low temperature region to high temperature region. So similar kind of things we can see in refrigerator, or we can say in air conditioning systems, okay, where the heat is transferred from low temperature region to the high temperature region, and for that purpose we require to perform the work on the system. So that work performance will be done by compressor, okay, compressor required in that particular case. Okay, so and to perform that work we require the energy, that is nothing but electrical energy. So compressor compress the air or that particular refrigerant by consuming the electrical energy. So that is nothing but what? We require some one external agency which will perform the work on the system. Okay, so second law of thermodynamics, heat will flow. Write down second law of thermodynamics. It will flow naturally. It will flow naturally from one reservoir to another, to another, to another at low temperature, at low temperature, at low temperature. But not in opposite direction, but not in opposite direction, but not in opposite direction, but not in opposite direction without an assistant, without an assistance, without an assistant. Okay, you may found there are different second law statements, but I'm in general I'm putting this particular statement. Okay, heat will flow naturally from one reservoir to another at low temperature, but not in opposite direction without an assistant, without an assistance. Okay, over. Any doubt, any question? Now our main topic entered over here. Okay, so now we have discussed about the thermodynamics. Now what is meant by heat transfer? So we discussed the definition of heat transfer. That is nothing but transmission of energy from one region to another region as a result of a temperature gradient or difference. Okay, as a result of temperature gradient or temperature difference. Okay, now this heat transfer takes place because of a three modes of a heat transfer. Which are that three modes? First one is a conduction, second one is a convection, and third one is a radiation. Third one is a radiation. Okay. So mainly, if you see in thermodynamics, we are dealing with the equilibrium state. Okay, if you check the definition of a thermodynamics, and I have mentioned over here that the equilibrium is most important word in thermodynamics, thermodynamic definition. Okay, so thermodynamic is the science which deals with the relation among heat and work and properties of a system which are in equilibrium. थर्मोडायनामिक इक्विलिब्रियम काय असू शकतो? आपण थर्मोडायनामिक इक्विलिब्रियमची डेफिनेशन पण बघितली होती. व्हॉट इज मीन बाय थर्मोडायनामिक इक्विलिब्रियम? थर्मोडायनामिक इक्विलिब्रियम असतो ज्यामध्ये टेम्परेचर डज नॉट चेंज विथ रिस्पेक्ट टू टाइम. ओके, टेम्परेचर डज नॉट चेंज विथ रिस्पेक्ट टू टाइम फॉर द सिस्टम. दैट इज नथिंग बट व्हाट? द थर्मोडायनामिक इक्विलिब्रियम. नाउ इन केस ऑफ heat transfer, what we are discussing? We are discussing that transfer of energy from one region to another region as a result of a temperature gradient or a temperature difference. So to transfer the heat from one region to another region, there should not be a temperature equilibrium or thermodynamic equilibrium, right? There is some logic. So how it is differ from thermodynamic? Okay, in thermodynamic we are dealing with the heat and work relationship amongst the heat and work at an equilibrium state. Equilibrium state means what? There is no further change in the temperature within the system. Okay, but for the heat transfer, you require the temperature gradient. That is nothing but non-equilibrium state required to transfer the heat. Non-equilibrium state is required to transfer the heat. Okay, now which is not found in a thermodynamic. Okay, non-equilibrium state is not found in a thermodynamic, so that this heat transfer subject is differ from the thermodynamic subject. Okay, so here we are dealing with the non-equilibrium system because we have to check whether there is a temperature gradient or not. If the temperature gradient is there, then and then only heat will be transferred from high temperature region to the low temperature region, and it will transfer because of three modes of a heat transfer. That is nothing but conduction, convection, and radiation. Getting everyone? समजतंय सगळ्यांना? समजतंय सगळ्यांना? Please mention in the chat box whether you understood or not. Please mention in the chat box. Is there any question? Is there any question? Okay. Okay, thank you. Great. Smart विद्यार्थी आहेत क्लासमध्ये माझ्या. आनंद झाला मला. If you have any feedback, then also you can give directly to me. I will without hesitation. Okay. मी त्यात चेंजेस म्हणजे जर तुम्हाला फास्ट वाटत असेल शिकवणं किंवा स्लो वाटत असेल किंवा काही प्रॉब्लेम वाटत असेल तर तुम्ही डायरेक्टली विचारा किंवा डायरेक्टली फीडबॅक पण देऊ शकता मला की सर इथे थोडस प्रॉब्लेमॅटिक वाटतंय आम्हाला किंवा हे समजत नाही तुम्ही शिकवलेलं, तर मी त्यात सुधार करून अजून काही बेटर देऊ शकतो का तुम्हाला, त्यावरती पण विचार करेल आणि डेफिनेटली मी काहीतरी नवीन घेऊन येण्याचा प्रयत्न करेल तुमच्यासमोर. ओके, सो I assume that you have written all the points because without this basic knowledge you can't move ahead or you can't dive inside this particular subject. Okay, that is heat transfer, very important subject, and you will found numerous application of this particular subject all over around you, surrounding to you in your home, in different types of industries. Okay, so the subject is important. For that purpose I cover some basic knowledge which will be considered as the foundation for this particular subject. Okay, so further we will discuss in the next lecture the difference between thermodynamic and heat transfer. Then we will take the conduction point, and the governing law related to the conduction, then further the convection, what is meant by convection, then governing law related to the convection, and the last the radiation and governing law related to the radiation. Okay, so that will be our uh, the points which we are going to cover in the, or which we are going to discuss in the next lecture. Okay, so I assume you have noted all the points uh, from this particular slides, and uh, we will study some points from the thermodynamics also, so that we will better understood what is the difference between the heat transfer and thermodynamics. Okay, so we'll stop here. If you have any doubt, you can ask. Else, you can put up your roll numbers and you can leave this particular meeting.